Chapter 7: Enhancing Components. So far we've learned how to mount and compose components to create application presentation layers with React. It is possible to build quite a few applications using only the React components render method. However, the world of JavaScript is complex. There is asynchronicity everywhere. We have latency to deal with when we load our data. We have delays to work with when we create animations. It is highly likely that you have preferred JavaScript libraries to help you navigate the complexity of real-world JavaScript. Before we can enhance our applications with third-party JavaScript libraries or back-end data requests, we must first understand how to work with the component lifecycle. A series of methods that can be invoked every time we mount or update a component. We will start this chapter by exploring the component lifecycle. After we introduce the lifecycle, we will review how we can use it to load data, incorporate third-party JavaScript, and even improve our component's performance. Next, we will explore how to reuse functionality across our applications with higher-order components. We will wrap up this chapter by looking at alternative application architectures that manage state entirely outside of React. Component lifecycles. The component lifecycle consists of methods that are invoked in series when a component is mounted or updated. These methods are invoked either before or after the component renders the UI. In fact, the render method itself is a part of the component lifecycle. There are two primary lifecycles: the mounting lifecycle and the updating lifecycle. Mounting lifecycle. The mounting lifecycle consists of methods that are invoked when a component is mounted or unmounted. In other words, these methods allow you to initially set up state, make API calls, start and stop timers, manipulate the rendered DOM, initialize third-party libraries, and more. These methods allow you to incorporate JavaScript to assist in the initialization and destruction of a component. The mounting lifecycle is slightly different depending upon whether you use S6 class syntax or React.create class to create components. When you use create class, getDefaultProps is invoked first to obtain the component's properties. Next, getInitialState is invoked to initialize the state. S6 classes do not have these methods. Instead, default props are obtained and sent to the constructor as an argument. The constructor is where the state is initialized. Both S6 class constructors and getInitialState have access to the properties and, if required, can use them to help define the initial state. Table 7:1 lists the methods of the component mounting lifecycle. Table 7:1. Component mounting lifecycle. S6 class React.create class. GetDefaultProps. Constructor props. GetInitialState. Component will mount. Component will mount. Render. Render. Componented mount. Componented mount. Component will unmount. Component will unmount. Class constructors. Technically, the constructor is not a lifecycle method. We include it because it is used for component initialization. This is where the state is initialized. So, the constructor is always the first function invoked when a component is mounted. Once the properties are obtained and state is initialized, the component will mount method is invoked. Th. Is method is invoked before the DOM is rendered and can be used to initialize third-party libraries, start animations, request data, or perform any additional setup that may be required before a component is rendered. It is possible to invoke setState from this method to change the component state just before the component is initially rendered. Let's use the component will mount method to initialize a request for some members. When we get a successful response, we will update the state. Remember the getForCheMembers promise that we created in Chapter 2. We will use that to load a random list of members from randomuser.me. Const getForCheMembers equals count equals new promise array solves rejects equals const API equals https://api.randomuser.me/nat equals useSalt equals count. Const request equals new smushed request. Request.openGet API. Request.onload equals request.status equals 200. Results JSON.parser request.response.results. Reject error request.status text. Request.oner equals reject set. Request.send. We will use this promise in the component will mount method in a member list component. This component will use a member component to display each user's picture, name, email address, and location. Const member equals email, picture, name, location equals member. Dot thumbnail alt equals / name dot first. Name dot last. Email. Location. Dot city, location dot state. Class member list extends component. Constructor. Super. This dot state equals members, loading false, error null. Component will mount. This dot set state loading true. getForCheMembers this dot props dot count dot then. Members equals. This dot set state members, loading false. Error equals. This dot set state here error, loading false. Component will update. Console.log updating lifecycle. Render. Const members, loading, error equals this dot state return. Equals member list. Loading. Loading members. Members.length. Members.map I equals. Key equals I, user / 0 members loaded. Error. Error loading members error. Initially, when the component is mounted, member list has an empty array for members and loading is false. In the component will mount method, the state is changed to reflect the fact that a request was made to load some users. Next, while waiting for the request to complete, the component is rendered. Because loading is now true, a message will be displayed alerting the user to the latency. When the promise passes or fails, the loading state is returned to false and either the members have been loaded or an error has been returned. Calling setState at this point will re-render our UI with either some members or an error. Using setState in component will mount calling setState before the component has rendered will not kick off the updating lifecycle. Calling setState after the component has been rendered will kick off the updating lifecycle. If you call setState inside an asynchronous callback defined within the component willNount method, it will be invoked after the component has rendered and will trigger the updating life cycle. The other methods of the component mounting life cycle include componented mount and component willUnmount. Componented mount is invoked just after the component has rendered, and component willUnmount is invoked just before the component is unmounted. Componented mount is another good place to make API requests. This method is invoked after the component has rendered, so any setState calls from this method will kick off the updating life cycle and re-render the component. Componented mount is also a good place to initialize any third-party JavaScript that requires a DOM. For instance, you may want to incorporate a drag-and-drop library or a library that handles touch events. Typically, these libraries require a DOM before they can be initialized. Another good use for componented mount is to start background processes like interp, vals or timers. Any processes started in componented mount or component willMount can be cleaned up in component willUnmount. You don't want to leave background processes running when they are not needed. Components are unmounted when their parents remove them or they have been unmounted with the unmount component @node function found in React DOM. This method is used to unmount the root component. When a root component is unmounted, its children are unmounted first. Let's take a look at a clock example. When the clock component has mounted, a timer will be started. When the user clicks on the close button, the clock will be unmounted with unmount component @node and the timer stopped. Import React from React. Import render, unmount component @node from React DOM. Import get clock time from /lib. Const component equals React const target equals document.getElement read React container. Class clock extends component. Constructor. Super. This state equals get clock time. Componented mount. Console.log starting clock. This ticking equals set interval equals. This set stage at clock time. 1000. Component willUnmount. Clear interval this ticking. Console.log stopping clock. Render. Const hours, minutes, seconds. Timmy of day equals this state return. Equals clock. Hours. Minutes. Seconds. Timmy of day. On click equals this props on close, x. Render. On close equals, unmount component @node target /target. In chapter 3, we created a serialized time function that abstracts civilian time with leading zeros from the data object. Every time serialized time is invoked, the current time is returned in an object that contains hours, minutes, seconds, and the AM or PM indicator. Initially, we call serialized time to get the initial state for our clock. After the component has mounted, we start an interval called ticking. It invokes set state with a new time every second. The UI for the clock changes its value to the updated time every second. When the close button is clicked, the clock component is unmounted. Just before the clock is removed from the DOM, the ticking interval is cleared so that it no longer runs in the background. Updating life cycle. The updating life cycle is a series of methods that are invoked when a component's state changes or when new properties are received from the parent. This life cycle can be used to incorporate JavaScript before the component updates or to interact with the DOM after the update. Additionally, it can be used to improve the performance of an application because it gives you the ability to cancel unnecessary updates. The updating life cycle kicks off every time setState is called. Calling setState within the updating life cycle will cause an infinite recursive loop that results in a Stack Overflow error. Therefore, setState can only be called in component will receive props, which allows the component to update state when its properties are updated. The updating life cycle methods include component will receive props next props. Only invoked if new properties have been passed to the component. This is the only method where setState can be called. Should component update next props, next state. The update lifecycle's gatekeeper predicate that can call off the update. This method can be used to improve performance by only allowing necessary updates. Component will update next props, next state. Invoked just before the component updates. Similar to component will mount, only it is invoked before each update occurs. Componented update props, previous state. Invoked just after the update takes place, after the call to render. Similar to componented mount, but it is invoked after each update. Let's modify the color organizer application that we created in the last chapter. Specify. We'll add some updating lifecycle functions to the color component that will allow us to see how the updating lifecycle works. Let's assume that we already have 4 colors in the state array: ocean blue, tomato, lawn, and party pink. First, we will use the component willMount method to initialize color objects with a style, and set all 4 color elements to have gray backgrounds. Import star rating from /components. Export class color extends component. Component willMount. This style equals background color CCC. Render. Const title, rating, color, onRate equals this props return. Class name equals color style equals this style. Title equals color. Style equals background color. Star selected equals rating. OnRate equals OnRate / color.prop types equals title prop types string, rating prop types number, color prop types string, OnRate prop types func. Color.default props equals title undefined, rating 0, color 0000000, OnRate f equals f. When the color list originally mounts, each color background will be gray. Figure 7:1. Figure 7:1. L. Mounted colors with gray background. We can add component will update to the color component in order to remove the gray background from each color just before the color updates. Component will mount. This style equals background color CCC. Component will update. This style equals null. Adding these lifecycle functions allows us to see when a component has mounted and when that component is updating. Initially, mounted components will have a gray background. Once each color is updated, the background will return to white. If you run this code and rate any color, you will notice that all 4 colors update even though you have only changed the rating of a single color. See Figure 7-2. Figure 7-2. Etting blue triggers update, and all 4 components update. Here, changing the rating of ocean blue from 3 to 4 stars caused all 4 colors to update because when the parent, the color list, updates state, it re-renders each color component. See. Components that are re-rendered are not remounted. If they are already there, an update occurs instead. W. When a component is updated, all of its children are also updated. W. When a single color is rated, all 4 colors are updated, all 4 star rating components are updated, and all 5 stars on each component are updated. We can improve the performance of our application by preventing colors from being updated when their property values have not changed. A. The lifecycle function should component update prevents unnecessary updates from occurring. This method returns either true or false, true when the component should update and false when updating should be skipped. Component will mount. This style equals background color CCC. Should component update next props. Const rating equals this props return rating equals next props rating. Component will update. This style equals null. The should component update method can compare the new properties with the old ones. The new properties are passed to this method as an argument. The old properties are still the current props, and the component has not updated. If the rating is the same in the current properties and the new ones, there is no need for the color to update. If the color does not update, none of its children will update either. When the rating does not change, the entire component tree under each color will not update. This can be demonstrated by running this code and updating any of the colors. The component will update method is only called if the component is going to update. It comes after should component update in the life cycle. The backgrounds will stay gray until the color components are updated by changing their ratings. Figure 7-3. If the should component update method returns true, the rest of the updating life cycle will get to it. The rest of the life cycle functions also receive the new props and new state as arguments. The componented update method receives the previous props and the previous state because once this method is reached, the update already has occurred and the props have been changed. Let's log a message after the component updates. In the componented update function, we'll compare the current properties to the old ones to see if the rating got better or worse. Component will mount. This style equals background color CCC. Should component update next props. Const rating equals this props return rating equals next props rating. Component will update. This style equals null. Componented update equals props. Const title rating equals this props. Const status equals rating previous props rating. Better worse. Console.log title is getting status. Figure 7-3. Of any update at a time which should component update. The updating lifecycle methods component will update and componented update are great places to interact with DOM elements before or after updates. In this next sample, the updating process will be paused with an alert in component will update. Component will mount. This dot style equals background color CCC. Should component update next props. Return this dot props dot rating equals next props dot rating. Component will update next props. Const title rating equals this dot props this dot style equals null this dot refs dot title dot style dot background color equals red. This dot refs dot title dot style dot color equals white. Alert title rating next props dot rating. Componented update ecred props. Const title rating equals this dot props const status equals rating previous props dot rating. Better worse. This dot refs dot title dot style dot background color equals. This dot refs dot title dot style dot color equals black. If change the rating of tomato from 2 to 4 stars, the updating process will be paused by an alert figure 7 to 4. The current DOM element for the color's title is given a different background and text color. Figure 7 to 4. Updating paused with alert. As soon as we clear the alert, the component updates and componented update is invoked, clearing the title's background color figure 7 to 5. Figure 7 to 5. Componented update removes the title highlight. Sometimes our components hold state that is originally set based upon properties. W. E can set the initial state of our component classes in the constructor or the component will mount lifecycle method. W. When those properties change, we will need to update the state using the component will receive props method. In example 7 to 1, we have a parent component that holds state, hidden messages. Th. Its component holds 3 messages in state and shows only 1 message at a time. When hidden messages mounts, an interval is added to cycle through the messages, only displaying 1 at a time. Example 7 to 1. Hi. Den messages component. Class hidden messages extends component. Constructor props. Super props. This dot state equals messages. The crow crows after midnight. Bring a watch and dark clothes to the spot. Jericho, Jericho, go. Showing -1. Component will mount. This dot interval equals set interval equals. Let showing messages equals this dot state showing equals messages dot length -1. Showing this dot set state showing 1000. Component will unmount. Clear interval this dot interval. Render. Const messages showing equals this dot state return. Equals hidden messages. Messages dot map message I equals. Key equals I. Hide equals I equals showing. Message. The hidden messages component cycles through each of the messages in the state array and shows 1 at a time. The logic for this is set up in component will mount. When the component mounts, an interval is added that updates the index for the message that should be showing. The component renders all of the messages using the hidden message component and only sets the hide property on one of them to true on each cycle. The rest of the properties are set to false, and the hidden is. Sage changes every second. Take a look at the hidden message component, the one used for each message. Example 7-2. When this component is originally mounted, the hide property is used to determine its state. However, when the parent updates this component's properties, nothing happens. This component will not know about it. Example 7-2. Hidden message component. Class hidden message E10's component. Constructor props. Super props. This dot state equals hidden props dot hide p props dot hide true. Render const children equals this dot props const hidden equals this dot state return hidden. C children dot replace /AZ/0-9 /G children. The problem occurs when the parent component changes the hide property. T have change does not automatically cause the state of hidden message to change. The component will receive a props lifecycle method was created for these scenarios. T will be invoked when the properties have been changed by the parent, and those changed properties can be used to modify the state internally. Class hidden message E10's component. Constructor props. Super props. This dot state equals hidden props dot hide p props dot hide true. Component will receive a props next props. This dot set stated in next props dot hide. Render const children equals this dot props const hidden equals this dot state return hidden. Children dot replace /AZ/0-9 /G children. When the parent component, hidden messages, changes the property for hide, component will receive a props allows us to update the state. Setting state from props. The previous code sample has been reduced to demonstrate the use of component will receive props. If this is all we are doing with hidden message, then we should use a stateless functional component instead. The only reason we would ever add state to a child component is when we want that component to change things about itself internally. For example, using component will receive a props to modify state would be warranted if the component required a set state call. Hide const hidden equals true. This dot set stated in show const hidden equals false. This dot set stated in return on mouse enter equals this dot show on mouse nav equals this dot hide hidden. Children dot replace /AZAZ0-9 /G children. In this case, it would be appropriate to store state in the hidden message component. If the component is not going to change itself, keep it stateless and manage the state from the parent only. The component lifecycle methods give us much more control over how a component should be rendered or updated. They provide hooks for us to add functionality before or after both mounting and updating have occurred. Next, we will explore how these lifecycle methods can be used to incorporate third-party JavaScript libraries. First, however, we'll take a brief look at the React.Children API.